or equilibrium of a section. As we said, this method is for the case that we don't have to find all member forces, only maybe one or two or three members are needed. The truss, maybe some members are broken, need to be replaced. You don't have to analyze the entire truss, find member forces and all members. You can only, you need to go only do one or two. So let's see what are the steps involved here. The steps are relatively the same, except for one or two cases. Step one, okay, is the same. You set up XY coordinates, which is always the case. Step two, you identify zero force members. In this case, in fact, identifying zero force members becomes sometimes very important, because there are times that you've been asked to find a member force, and as you will see following these procedures, no matter how you cut it, you end up with more unknowns than number of equations that you have. Then you realize, oh, wait a minute, maybe I forgot to get rid of some of these zero force members. So taking care of zero force members is an important step. Then once you got rid of those zero force members, this is what you do. You will consider the member that you want to find its force and cut the member. So when I say cut the member, meaning the member that you've been asked to find its force, and as few as possible other members. This is really the heart of this procedure, because if you're not careful enough and not perform that section cut properly, you make life a little bit difficult on yourself. Okay? Then step four, if needed, okay, find support reaction forces. This is the case that when you perform this cut, you look at each of those three-body diagrams, you realize that in order to be able to solve the problem, solve for all the unknowns, you need to know what the reaction forces are. It's not necessarily the case all the time, but it depends on the situation. In fact, we'll solve some problems to see how that works. So once you do that then, okay, then step 5, consider the free body diagram with least number of unknowns, because you've cut the truss into two pieces. Depending on which piece, you may have more unknowns in one than the other, okay? And then step 6, apply equations of equilibrium. Remember, now you're not considering the equilibrium of a joint, but equilibrium of a piece of a truss. So in the case of equilibrium of joints, you were dealing with the particle equilibrium. Now you're talking about the rigid body equilibrium. So you have 3 equations of equilibrium to work with, okay? So apply, remember always this as the first equation. Why? Because you can get rid of 2 of the unknowns that you don't need by taking summation of moments about the point of intersection of those 2 unknowns, okay? And step 7 is, of course, verify your answers. Okay. So let's do a few problems. I'm going to do, I think I can do 3 problems because I could do 3 problems in the other section. So I better do actually 4 in this section. How about that? So let's just start with this one. Okay. Let's see. I have a truss that looks like this. It's supposed to be symmetric. So you have a force of 600 pounds at one node and another 800 pounds at another joint. So let me label these A, B, C, D, E, F, G. The dimensions are given. This is 10 feet. Okay, and these are 10 feet, 8 feet, and 10 feet. And this is, of course, in the middle, so this is 4 and 4. So the problem is asking you to find these member forces. Member force EC, okay, member force EF, and FC. Remember that you may or may not be able to find more than one unknown by using one of the free body diagrams that you come up with after you cut the truss, but that is not necessarily the case. You may have to do one free body diagram for each, or one section for each. The governing criteria is this: cut that member and as few as possible other members. So let's look at this truss. The first one I'm going to find is which member. Let's say I want to find member in that order that was asked. Let me do that in that order. EC, okay? So if you want to cut this one, you can cut the truss like this, right? But then you have 1, 2, 3, 4 members you've cut, or you can cut it like this. 1, 2, 3 members you've cut, which includes that member. So which one we consider? The one with the least number of members or least number of unknowns. So I would consider obviously this a cut. That's preferable. So what it means that I need to cut this member and the truss in such a way that that member is included. So you end up with 2 pieces here. Okay? So you have this free body diagram and this free body diagram. Okay? Now, if you look at either of those 2 free body diagrams, as I said, although they have the same, we don't have, of course, lateral load, so they both have the same number of unknowns. However, they have more unknowns that we can solve for. 1, 2, 3, 4, 1, 2, 3, 4, because 5 is 0. So in this case, I need to find support reaction forces, because otherwise I cannot use that free body diagram to find all my unknowns. So that's what I would do. I will find these reaction forces. At least I only find one of them. So I will take summation of in the free body diagram of the original free body diagram of the entire trust, let's take summation of moments about A is equal to 0. So I will have RD times 28 minus 800 times 18 minus 600 times 10 equal to 0. And that will give me RD comes out to be is 729. So I have this force now, 729 pounds. Now I can look at this free body diagram. I have three unknowns. I want to find this member force, right? This guy, right, FC. What is the easiest way to find that force now in that free body diagram? How do I find it? The quickest way to find that force? Which equation of equilibrium can I use to give me that force quickly? This unknown, this unknown, this unknown. I have three equations of equilibrium. For y, yes, summation of forces along y is equal to 0. I only have one unknown, right? So F of EC minus 729 is equal to 0 in this free body diagram. I'm considering this free body diagram. So F of EC comes out to be 729 pounds. So the assumed direction is correct because that came out to be positive. That means force is moving away from the joint. Therefore, this is in tension or compression? Tension. So that's that force. So I found that one. So I've got this force. The next one that the problem is asking is to find member force EF. EF. Can I use the same free body diagram to find that force? EF. And if so, what is the best equation to consider if I want to find this force? This was force of EC. Now I want this force of EF. How do I find it? It's Friday afternoon. How about summation of moments about D is equal to 0? I have this known, this one unknown, so I have only two unknowns. One unknown, I can find that, right? So take summation of moments about D. I have F of EC, which is 729 times 10, right? And F of EF is also assumed to be going counterclockwise times that one is also 10 equal to 0. So F of EF comes out to be negative 729 pounds. That means the assumed direction is wrong. So the assumed direction has to be changed. The correct direction is then this way, right? That means the corresponding member, EF, is in tension or compression? Compression. Okay. The last one is member FC. Obviously, I cannot use either of those two free body diagrams because member FC is not cut. So I have to consider a section that includes cutting that section, that member, and as few as possible other members. So I'm going to, since I don't want to redraw things, I'm just going to put this truss back in the shape it was, okay? And I have to cut this member now. member, okay, FC. And the way to cut that in such a way that I've cut the fewest number of members is this one, right? Because I can cut it like this too, but I've got 1, 2, 3, 4. So this way I cut only 3. So if I do that, then I have these 2 free body diagrams.
When we write it on like the homework and stuff, do we have to?
It's a
make
good
separate free
idea
body
to,
diagrams for
yeah,
each
it's a
single
good
thing?
idea to do definitely separate free body diagrams. Especially cases like this, you're dealing with 2 completely different free body diagrams, right? So this is the force that I want to find, right? FC, right? Let's assume it is this way. This one actually I know EF was compressive, so it was like this. And I have that force, okay? So I consider this free body diagram, right? And I have this one and this one unknown. How do I find only this force? Because I don't need this one. I just need to find this one. By the way, the slope here is given. This is 10, 4, or 5, 2, or square root of 29. So how do I find that force? Remember Mr. Saint Paragon. Right, if you resolve this into its component, this component goes through that point, this unknown force goes also through that point. So if I take summation of moments about D is equal to 0, right, I only have the vertical component clockwise, so that'll be 5 over square root 29 F of CF, right? Negative, counterclockwise, and clockwise. Then I have this force, which is positive 800 times 10 is equal to 0. And I have, of course, this one, which is also clockwise, so I have to add that also, sorry. Negative 729 times this distance, which is also 10, okay? So is equal to 0, okay? If you solve that, you see that FCF comes out to be positive. I have the answer here. FCF comes out to be 76.9. And comes out to be positive, that means the assumed direction is correct. So this is in tension or compression? Come on, it's not too bad. Okay. Tension or compression? Tension. Okay. That's it. Easy, right? The thing about method of sections is that you just need to do more thinking, being a little bit more creative. And method of joints is relatively straightforward. You start with a joint with a minimum number of unknowns and move forward. Here, you have to consider a section that includes that member and as few as possible other members, okay? And then, when it comes to applying the equations of equilibrium, you have to be a little bit thoughtful. Do it in such a way that you only find the unknown that you've been asked to find. For instance, in this, I could have also used summation of forces along X and find this one, but I don't need that. I've been asked to find that, okay? All right, so let's do another problem. Any questions? You've had a long week. Looks like it.
Really fast for the MD.
Yes?
Is it negative 5 over 29 FCF times 10? Would be like.
Oh, this one, yeah, times 10, yes, you know, I'm so excited. Right.
And when I calculated it, I got not the same answer as you
You
did.
don't? I don't know, I have the answers here. So we can discuss that, I don't know why. Okay, all right, so, let's see. I'm gonna do another relatively good problem here. This one is a bit easier, but it's worth doing it. So let's see. Let's say we have a So you have a truss that is loaded like this. So let me label these joints A, B, C, D, E, F, G, H, I, J. Let's see, these distances are given. 1.5 meter, 1.5, 1.5, 1.5. This is 2 and 2 meters. So the problem is asking you to find forces in member IC, CG of this truss, okay? So step 1, set up X and Y. Step 2, 0 force members. Now you see that in this truss, if you don't find the 0 force members first, you run into a little bit of problem. Let's say you want to find member force IC in this member. You have to cut that in such a way, you cut that and as few as possible other members, right? So if I cut this this way, I have 1, 2, 3, 4. If I cut this way, I have 1, 2, 3, 4, 5. If I cut this way, I got 1, 2, 3, 4, 5. There's no way that I end up with fewer than 4 unknowns. However, there's something missing here. And I have not been careful, right? What is that? 0 force members. Do I have any 0 force members in this truss?
H.
H is not a member. HI is a member. So if you look at what you meant is, look at joint H, satisfies those 3 criteria. No load, 2 are collinear, therefore this one goes. What else? IG now is a 0 force member. Do we have any more? Come on. You must be really tired.
JG.
J,
AC.
AC? How could that be? A, B, and B, C. You have a joint with only 2 members, and there's no load acting there, right? Wasn't that one of those wonderful special cases that you should really be careful and watch out for, right? If you look at the equilibrium of that joint, that tells you both of these would go. Same thing with this guy then, right? So that truss is not as big in terms of number of members as you thought, due to this loading condition, I emphasize. So then, now, you cut, IC is gone, I call it, I is gone. Cut AC, and as few as possible other members, right? So, obvious, this would be the best cut, right? And then consider 2 free body diagrams and choose the one with the least number of unknowns. Here it is. I'm gonna cut this, so I have probably forces like this, right? So I can either consider this free body diagram or this free body diagram, okay? Again, look at it, okay? Which one is better to consider? Right or left? Who votes for right? Why?
Because you need more of it.
I want to find, I don't care, I just want to find force AC. And you said right is better.
Yeah.
So how do you find that?
Well, it's a roller on E instead of a pin at A, so then it's only one unknown.
Right, but how do I find AC?
F1.
Force of AC. Yes, you said it. I think you deserve that 2 points. Yes. If you take summation of moments about E is equal to 0, right? Again, this unknown disappears. You don't need to worry about it. So you only have one unknown here. So what is the slope here? This was 4 and 3 and 5. So as they're saying, very on, 3/5 FAC, 4/5 FAC, right? Take summation of moments about E, you have 6 times 1.5, you have 6 times 3, okay? Then you have 3/5 FAC times 4, you have 4/5 FAC times 3 is equal to 0. It is clear that FAC is going to come out negative. I have, fortunately, the answer here. F of AC, or I see a 5.62. F of AC comes out to be negative 5.62 kilonewton. A negative value tells me the assumed direction is wrong, so I would correct that, right? So that's what it should be. In other words, this is that way. So the corresponding member is in tension or compression. Force going towards the joint, therefore this is in compression. So that's that force, right? So we're done with this. How about CG? As you can see again, I cannot use that same free body diagram to find that force CG. I need to consider a section that would cut that and a few other members as possible. So I'm going to put this guy back in its original shape, okay? And now I want to find, okay, a member CG, this member. So I need to cut that and as few as possible other members, right? So what do you recommend?
Cross.
You mean like this?
CACG.
You mean like this?
Yeah.
Is that a good idea or a bad idea? Why not this? I'm not saying you're wrong, right? If I consider this, right, and I want to find, so what you're suggesting, what he's suggesting, maybe I do it here, okay? We have two opinions here. One says, consider this one, we already have member AC, that is actually in compression. So this member, I don't know if that is in compression. This is AC, I have that is 5.62. Then I have member CG that I want to find, and this one, I don't have member CJ. So two unknowns, right? So how do you find that? If you use that section Since you said it, you can offer the solution.
So you have FIC. You wouldn't, because you can't like moment or anything, and you don't have FCJ. So
No.
I guess that's not right.
So you have two unknowns and two equations though. If you write summation of forces
Forces what?
along y equal to 0, you can find f of Cj, right? Cej, I'm sorry. Right? And then you write summation of forces along, along x. Summation of forces along y equal to 0, then you find f of Cg, right? Which is what you want. So that is okay. However, as I said, even in the cases that your section gives you the same number of unknowns, you always try to find the easy way out. I don't like to solve two equations, especially Friday afternoon, right? So, how about this? If I cut it like this, what happens? You see it, where I'm coming from now? What happens? Do you see it? So is it better? You have only one unknown, because here, if you consider this free body diagram, then you write summation of moments about E is equal to 0, right? And you have only this guy that you were looking for, FCG. So you have negative FCG times 3, okay? And then you have positive 6 times 1.5 plus 6 times 3 is equal to 0, okay? And you don't have to even worry about, because here you had to do some little bit of geometry and trigonometry and all that good stuff, right? Find the components of this and that. This way you don't. So that will give you FCG, and apparently the assumed direction is correct. FCG comes out to be 9 kilonewton. And this is the assumed, this is the correct direction, so that would be in tension. Okay. So with the method of sections, you do need some practice. What do you need to emphasize on and focus on? How you cut it, number one. After you cut it, and you look at those free body diagrams, always remember, engineers take the easy way out, the minimum path, right? So try to do it in such a way that you only find the unknown that you've been asked to find. Don't find other unknowns. I was not asked to find this member, so why should I worry about it? So if that's the question asked, think about it and use the equations of equilibrium in such a way that you only find that particular unknown. And it's always possible. Okay? Let's look at another problem. Okay. Any questions? Okay. I'm going to do a problem that was, in fact, I think an exam problem, maybe 2-3 years ago. It was a final exam problem. So must have been a good problem, right? Well, you're so quiet today. Something, maybe it's the rain or something, no? Okay. So let's see. Okay. Okay, this is a good typical problem that is good for thoughts. Here you've been asked to find the force in member GC. So let's again start step by step. XY coordinates, you set that up. Number 2 is what? Zero force members. Do you see any zero force member in this truss? BG. You look at B, 3 members coming together, no external load, 2 are collinear, so this goes. Right? Any more? CF. 3 members come together, no external loads, 2 are collinear, this one goes. What else? Which one? CD and ED are both zero force members again. A joint with 2 members and no load acting at that joint. This is gonna go. Okay? Now you've been asked to find this member force, right? So I will cut that and as few as possible other members. So looks like this is not a bad cut, although you can also cut it this way, but you end up with 3 unknowns there. And I'm going to find this unknown in such a way that really, in fact, the problem statement was find CG using only one equation of equilibrium. So even if you try to find it using method of joints and several equations, you would not get any credit. You have to use only one equation. So this is what we're gonna do. I'm gonna cut it like this, right? So we have these 2 free body diagrams. Which one do I consider? You answer questions usually good. So what do you suggest? Which one of these should I consider? Which free body diagram? If you consider the left one, in fact, it's one of those cases that, as I said, sometimes when you end up with 2 free body diagrams, right? Right? So remember, when it was cut, then consider the desirable free body diagram, right? And then apply equations of equilibrium. Look at these 2. There's no way you can solve that problem. You have 4 unknown support reaction forces and 3 here, so you have 7 unknowns. I just say Almighty would help you. Okay, so here at least you have 3 unknowns, right? So why don't I consider this? Okay, and I only want to find this force and nothing else. What do I do? Any suggestion? No? Who said it quiet? Yeah. How do you do that? Summation of moments about E is equal to 0. You eliminate this one, but you end up with 2 unknowns. I only want one equation. Just one.
Would be the forces of Y.
If you take summation of forces along Y, you have these 2 unknowns, so you're stuck. I only need one equation. Remember going way back when we were learning about the alphabets of statics? We said when you have 3 unknowns and you want to only find one of them, what do you do? Summation of moments about where? Point of intersection of those two unknowns that you want to get rid of. Do you see that here?
I see.
Where is it?
See. Wait.
No.
Wait, how is that not C? Wait.
I want to find this guy. These are the guys I don't want them,
Wait, what? Oh.
right?
Some are way off.
So, why not? Finding a point of intersection of these two, I can't do that. Right? And I know what that distance is, I can find that distance,
You gave
right?
this to them on the final?
Yes, it's a good problem,
Okay, wait.
right?
Oh, wait.
It's a very good problem. If you can see that, it's a 5-minute problem, right? So this triangle and this triangle are similar. So x over this distance, which is x plus, this was, I erased it, was what? This one was, how much was that one? This was 18, right? No? I think so. That was what, 18? Yeah, that was 18. X plus 18 is equal to 6 over 18, or 1/3. So that'll give you x is equal to 9. So you find x is equal to 9. Then you would think about, let's say, same varigon, right? You have, this is slope, right? This was 6, this was 18. You can find that, what is it, 12. So you just basically take summation of moments. So this would be what? The slope here then would be 1, 2, square root 5, okay? So you have moment of that guy, which would be positive, so that would be 2 over square root 5, force of CG times this distance, which is 9 plus 6, 15, okay? And this guy, okay, which is plus 20 times 9, and then this guy, which is 10 times 15, 9 and 6, 15, is equal to 0. That will give you FCG, which turns out to be negative because the assumed direction was wrong. And FCG comes out to be 24 kilonewton. So assumed direction is wrong. That means this has to change. So this is the correct direction. So the force in that is a tensile force. Okay. Remember the concepts. We learned about that when we started talking about equilibrium of rigid bodies. Summation of moments is the most fascinating equation that you ever encounter in life, because it eliminates two unknowns immediately, right? If two unknowns intersect. Well, we have 2 minutes. I promise that I do more problems if I
Would
find
it be
the time.
compression?
Would that be in compression? So this would be, oh, this, why did I draw it this way? It should be the other way, right? So it would be compression, right? Okay, so let me do another quick but really good problem. This was also some exam problems or something in the dark ages, okay? So this one I will just be quick. I think if I'm not mistaken, we may have actually done this problem using method of joints. It may be wrong, but I remember something related to this problem. You tell me. Okay. So this is 3 meters. At least let's do part of this, which is the important part. Okay? So you have a force of 50 Newton here, another 50 Newton here, A, B, C, D, E, F, G. And here you've been asked to find a force in member BC, this one. And of course BE, but let's just focus on that one. Step one is clear. Step two, zero force members. Do you see any zero force members? C, D, and D, E. So those are gone. Then what happens? BC, 3 forces, 2 collinear. This one is gonna go so as if this force is acting here, right? Okay, so if I really want to find this force, right, you consider a cut like this. You have 2 equations, 2 unknowns, you find it. So we don't have time, so see you on Monday. I sent you a whole bunch of problems for the exam. You can review those.